Hello everyone, welcome back to this channel. If you're new here, don't forget to hit the subscribe button for more in-depth discussions about artificial intelligence. Today we have a controversial topic. We are exploring the emergence of artificial general intelligence in large language models. For those that have never heard of the concept of artificial general intelligence, a simplistic definition would suffice here. Think of it as a form of machine intelligence that can understand, learn, and apply knowledge across a wide range of tasks, much like a human can. Now, let's set the stage. Large language models, commonly known as LLMs, have been making headlines, especially with the rise of technologies like ChatGPT. These models have done some truly fascinating things, sparking the imaginations, but also causing some to make rather alarmist claims about the potentials of the emergence of artificial general intelligence. We can trace some of this hysteria back to a property of large language models observed by a group of researchers from Google and Stanford, who published a paper in 2022 titled Emergent Abilities of Large Language Models. But what do we really mean when we talk about the emergent abilities of large language models and how that may indeed relate to artificial general intelligence? That's what we're here to unpack today. Before we proceed, I'd like to take this opportunity to shamelessly plug my course. If you're looking to gain practical experience in applying artificial intelligence, I've got just the thing for you. I'm releasing a course where I take you step by step through building your first large language model powered application. If it sounds like something you'd like to participate in, please sign up through the link in the description. Now that the shameless plug is over, let's get back to the main topic of this discussion. So first off, it's best that we understand what we mean when we say emergent abilities. Well, our group of researchers have given us a pretty straightforward definition. Our researchers have provided us with a clear definition of emergent abilities. So they say, specifically, we define emergent abilities of large language models as abilities that are not present in smaller scale models, but are present in large scale models. Thus, they cannot be predicted by simply extrapolating the performance improvements on smaller scale models. Okay, if that was a bit of a mouthful, we could term it like this. As these models get bigger, they start showcasing skills and abilities that their smaller versions just didn't have. Intriguing, isn't it? Now, have a look at this chart from the same research paper. Pay close attention to chart A. Researchers assess the accuracy of two model architectures, Lambda and GPT-3, at various model sizes. So it's important to note that each point on the chart is a different model size for that given architecture. So the purple here is GPT-3 architecture and the blue is Lambda. You'll notice that the models hit a certain size threshold where the performance on tasks improves dramatically and seemingly unpredictably out of nowhere. Now, for GPT-3, this noticeable improvement occurs after 6.7 billion parameters. And for Lambda, it's after 29 billion parameters. And we're talking specifically about the improvement on modular arithmetic. Paying close attention to these charts, you can see researchers have been able to map this capability, this improvement across various different logical tasks. This is what they refer to as emergent capabilities. So what does this mean? And could reasoning abilities just spontaneously appear when models reach a certain size threshold? It's certainly a fascinating question. The discovery of emergent capabilities led to some really critical questions. For example, which abilities would emerge next? And how do we predict and control the emergence of abilities? And maybe more pressingly, could artificial general intelligence unexpectedly emerge from a super large language model? Obviously, the potential for artificial general intelligence to emerge has sparked debates, discussions, and even some fears. You might remember the Pause Giant AI Experiments open letter published back in March 2023. Let's have a look at some of the alarming statements made in this open letter. OpenAI's recent statement regarding artificial general intelligence states that at some point, it may be important to get independent review before starting to train future systems, and for the most advanced efforts to agree to limit the rate of growth of compute used for creating new models. We agree that point is now. Here's another alarming statement from the open letter. This does not mean a pause on AI development in general, merely stepping back from the dangerous race to ever larger, unpredictable black box models with emergent capabilities. So it's clear that there are concerns about not only the scale of AI experiments, but also the propensity for emergent capabilities of super large, super massive models. However, there is a plot twist here. A separate group of researchers from Stanford University appear to have debunked the narrative of emergent capabilities in large language models. They argue that these so-called emergent capabilities are actually more about how the original group of researchers chose their performance metrics rather than some property of the models themselves. In their research paper, they showed that metrics such as accuracy used to assess the performance of large language models are nonlinear and therefore induce the emergent capabilities. In layman's terms, the emergent capabilities were more about the metrics chosen than some property of the size of the model itself. Let's look at a hypothetical example to illustrate. Let's say we asked a model to perform a 3-digit addition, 323 plus 456, let's say. The correct answer to this addition is 779. A larger model might get this completely correct, whereas, let's say, a slightly smaller model might return 650 as an answer. Let's introduce, for argument's sake, an even smaller model that returns the answer as 500. Now, pay close attention to the charts on screen. Consider the two incorrect models. Both would be deemed equally inaccurate if assessed solely by the accuracy, even though one is quite clearly more incorrect than the other. Therefore, when we use the accuracy metric, the emergent capabilities seem to appear unpredictably out of nowhere. And you can see this on the left-hand side here, because the small model, having gotten the answer as 500, has an accuracy of 0. The medium model, having returned an answer of 650, still has an accuracy of 0. It's only when the large model gets the answer completely correct at 779 that the accuracy shoots up to 100%. And that mimics what we're seeing with the emergent capabilities in our first research paper. Stanford researchers found that when they used metrics reflecting the degree of proximity to the correct answer, model performance became predictable with size and the emergent properties disappeared. Look at the chart on the right-hand side to illustrate this, showing a more linear relationship between model size and performance of our task. And that's because we're using, instead of a model accuracy, we're using distance from the correct answer as our performance metric. And we can see the median model is just halfway between the performance of the small and large model based on that metric. This is obviously more predictably linear. Of course, this is just a hypothetical example, but it captures the essence of how the emerging capabilities paper was essentially debunked. I have put links to both papers in the description for you to read for yourself. To conclude, the idea that artificial general intelligence might just spontaneously emerge from large language models is, at least for now, more science fiction than it is scientific fact. If artificial general intelligence is going to happen in large language models, I guess this evidence suggests that we may probably see it coming. For anyone engaged in artificial intelligence, it's crucial not to be swept away by the hype. Always scrutinize who sponsored the research and what they might gain from generating buzz. The advancement in large language models are indeed groundbreaking, but to leverage their full potential, we should approach them with an open but sober mind. Thanks so much for watching. If you found this discussion enlightening, please give this video a thumbs up and don't forget to hit the subscribe button if you haven't already. Until next time, take care.